The next topic we are going to see is copying arrays. So copying arrays means we have an array created. From that array, we need to copy the elements to another array. So we can use three methods for doing so. First one is using np.empty like function. So second one is using np.copy function. So third one is by using assignment operator. So we will be seeing in detail about each and every method. So in the first method, we use empty like function to create a matrix similar to that of the original matrix. The main use of this np.empty like is the new array which is created will have the same shape and type as that of the given array. So this is the syntax. So numpy dot empty like a comma d type equal to none, order equal to k, and sub ok equal to true. So we'll see an example for this. So as usual, as I've told you, in order to use Python code library, we'll have to import them. So we are importing numpy as np, and array we are giving a name as ary. So in this we are creating an array np dot array, and the elements are placed like this. So if we print the original array, the same elements will be printed. Okay. Second one is creating an empty numpy array similar to ary. So this is a function which we have defined in the previous slide. So the syntax goes like this. We'll have to put like copy equal to np dot empty like array. Now what happens? So now an array, okay, it is created with the same properties as that of the original array ary. Okay. So after that is been done, the elements from the ARY is copied. Okay, so it is assigned to the copy variable. So after that is done, if you print, so both the ARY and copy will have same number of elements. So next, by means of using np.copy function. So the syntax of this np.copy function will be numpy.copy a comma order equal to k comma sub ok equal to false. Okay, so A refers to the original matrix and order refers to the dimension. So third one is sub OK. So sub OK parameter in copy function determines whether the copy should be a subclass of the original arrays class in case if it is true, or a basic n-dimensional array in case if it is set as false. Okay, so we are next importing the numpy array. So original array, we are setting the elements, some values are given. Then we are printing the original array. Now if we use this function np dot copy, okay, so what happens? This original array is copied to this copy array by means of using this np.copy function. So after that has been done, if you print the copy array, we can find that both the original array and copy array will have same elements in them. So third method is by means of using an assignment operator. So we'll see an example or code for this. So we are importing the library. Okay, then we are defining a original array. So these are the elements in the array. Then we are copying the array from the original array to copy array. So we are going to use this assignment operator. So equal to is the assignment operator. Okay, so by means of doing so, all the elements from the original array will be copied to the copy array. So one thing we'll have to note here is, suppose if you are replacing any element in the array with some other value, for example, we use this operator, assignment operator. Okay, so see, in this matrix, the first two elements will be 99, 22, 33, and second row elements will be 44, 77 and 66. But whereas we are replacing the first row. Okay, which means this is zeroth row, this is first row. Okay, and second element. So this is zeroth element, first element, second element. So first row, second element is this. So this value will be replaced by 13. Now, if you print the original array and copied array, you can find 99, 22, 33 is printed as it is. 44, 77 is also printed as it is. And this 66 is replaced with this 13 and it is copied to the copy array also. So if you print both the arrays, we can find out that there is a change in the value of the array. So next we go for iterating arrays. So iterating array means we are going through the elements one by one. Okay. So generally we deal with multi-dimensional arrays in NumPy. That is the main use we go for NumPy in order to deal with multi-dimensional arrays. So iterating arrays is similar to looping kind of a thing. Okay. So let us see how to iterate a one-dimensional array. Okay, so what happens? We are importing the library, we are defining an array. So if you give it like this, for x in the array, so print x like this. What happens in this one-dimensional array? Okay, so particularly each and every element is iterated and printed. Okay, so for x in 1, okay, print x means so 1 will be printed. For x in for 2 in array, okay, print x means 2 will be printed and so on. So each element will be printed one by one. So next is iterating two-dimensional arrays. So if we want to iterate a two-dimensional array, it will actually go through all the rows. So, but if we iterate on an n-dimensional array, it will go through n minus 1 dimension one by one. So see, if we give like this, arr equal to np dot array 1, 2, 3, 4, 5, 6, and if we are giving for x in array print x, what happens here? So all the rows will be gone through and it is printed like this. So 1, 2, 3 is printed and 4, 5, 6 will be printed. Suppose if we want to print the elements in two-dimensional array, element by element, as we have done in one-dimensional case, then we have to follow this thing. Okay. So what happens? For x in array, we'll have to give another loop. This is called as nested loop. Loop inside another loop. So after giving for x in array, we'll have to give for y in x. So this is actually what we call it as nested loop. So one loop within another. So what happens? This will help you to print all the elements in the two-dimensional array one by one. But we will have to understand the difference in the previous case by means of using only for x in array loop. Okay, what happened? Each and every row was printed. So if you want to print elements individually like this, then you have to go for nested loop. So next we'll go for iterating three-dimensional arrays. So in a three-dimensional array, it will go through all the 2D arrays. Okay, so similar to what we have seen in two-dimensional array. So we are defining an array here. So if we simply give like this for x in array, print x, then what happens? Each two-dimensional, see all the two-dimensional arrays are, it will go through all the two-dimensional arrays. Okay, so means if it is a n dimension till it goes till n minus 1. Okay, so what happens? So 3D array, it will go through all the 2D arrays. Okay, so what happens? 1, 2, 3, 4, 5, 6 is printed first, after which 7, 8, 9, 10, 11, 2 is printed in the second line. Okay, suppose here also if we want to print each element by element, then what we have to do? We'll have to go for nested loops. So that is what is shown here. Okay, so we have defined the array here. So since this is three-dimensional, we need to go for three number of loops. Okay, so for x in array, for y in x, and for z in y, print z. If you give it like this, then what happens? all the elements in this three-dimensional array will be printed one by one. So this is what we call it as iterating a three-dimensional arrays. So we also have another way to iterate the arrays using ND iter. Okay. So what actually ND iter do? It creates an iterator that goes through all the elements of the array regardless of the dimensionality. So, in basic for loops, iterating through an array, we need to use n for loops, which can be difficult to write for arrays with higher dimensionality. So, if we are dealing with the high dimensional arrays, okay, so it is very tedious to write that many number of loops or iterate that many number of loops. So, in that case, we can go for ND iter. So, what happens here? We are giving an array, then you are giving for x in np nd iter array print x. So this will help to, this here the example we have seen is only two-dimensional. So this we can even do it with the earlier methods we have seen, but whereas if the dimensionality is increasing, then that many number of iteration loops you'll have to put, so which becomes very difficult. So that is the major use of going for a ND iter. So next we will see how to create an identity matrix. So identity matrix, one important thing you'll have to understand is an identity matrix is always a square matrix. Okay, so which means the number of rows and the number of columns will always be equal and the leading diagonal will have ones. So if you are giving np.identity of 5, okay, so 5 with 5 rows and 5 columns, a matrix will be created and the leading diagonal will be filled with ones and rest of the values will be filled with zeros. So this is what we call it as an identity array. Okay, so we'll see the syntax how to generate an identity matrix. So we can create it by using this function numpy.identity n comma data type equal to none. So n tells the dimensionality. Suppose if I want to create 3 dimension, I give it as 3. So d type refers to the data type. Okay, so by default float values are placed. If you want to change the data type, you can mention it in this place. Okay, so we are seeing a code here, import numpy as np. Suppose if we give np.identity of 4, this will help to create a 4 by 4 matrix with the leading diagonal ones and rest of the values will be filled as 0. So as I have told you, by default it is considered as a float value. So if you want to make it as integer, you have to mention it in the syntax itself. Okay. Okay, so we are seeing an example here. So suppose if you want to create a 2 by 2 identity matrix with the data type as float, you can give it like this, np dot identity of 2. So this will create a matrix with the 2 rows, 2 columns and ones in the leading diagonals. Similarly, if you want to print a 4 by 4 identity matrix, you can do so like this. So 4 rows, 4 columns will be are present and in the leading diagonal you'll have ones and zeros elsewhere. So the next function which we are going to see is EYE. Okay, so the syntax for this is numpy dot I of r comma c equal to none, k equal to 0, data type equal to float or integer or anything we can define that. Okay, so this function is used to return a matrix which will have 1 on the diagonal and 0 elsewhere. Okay, so r refers to the number of rows and c refers to number of columns. If we do not explicitly mention the value for C, then by default it considers R equal to C or number of rows equal to number of columns. So you can define whether it is an integer or float, anything in this place. Okay. And if we want to shift this ones to this place. Okay, so now actually the ones are present in the leading diagonal. If you want to shift it to a diagonal above the leading diagonal, which means this place, what we have to do, we have to set k value equal to 1. Similarly, if you want to shift this ones to this bottom place, then you have to mention k is equal to -1. So as I've specified earlier, data type is generally set as float by default. So you can see an example here, np.i of 4, it will return a 4 by 4 matrix. So since we have not defined the column value, by default it takes the column value also equal to 4 and returns a 4 by 4 matrix. So if you want to create a 3 by 2 matrix, okay, so 3 rows, 2 columns, and along the main diagonal 1 will be filled. See 3 comma 3 comma 1. So I've told you, right, k value is set as 1 here. So what happens? See, this is your main diagonal. So what happens? It gets shifted since we have set the k value as 1. Similarly here k value is set as -1. So what happens? This is the main diagonal. Below the diagonal the values are shifted. So one important thing or one important difference you can find with respect to identity matrices, see, identity matrix is always a square matrix, which means the number of rows and number of columns are always equal, and in the leading diagonal or main diagonal we have ones and rest of the values will be filled with the zeros. And also we cannot change the diagonal here, like we cannot set k equal to 1 or -1 as in the case of I. But whereas this np.i, it need not be specifically a square matrix. We can define or change the number of rows and number of columns for this np.i matrix, and we can accordingly set the value of k for shifting the diagonal. Okay, so if you want to shift it above, you give k equal to 1 and rest of the values will be put as 0, and if you want to shift it down, you can set k equal to -1. Okay, so that is the difference between the identity matrix and I matrix. Okay, so you could see some examples here. So next comes the shape of the array. So we are generally giving an array here. So if we use this function array.shape, this will print the shape of the array. So how many rows do we have here? 2 rows and 4 columns. So output will be 2 comma 4. But 2 refers to number of rows and 4 refers to the number of columns. So reshaping means we can change the shape of the array. So shape of the array is the number of elements in each dimension. So what we can do by means of reshaping, we can add or remove dimensions or change number of elements in each dimension. So if we want to reshape a one-dimensional array into two-dimensional array, so we can see an example here. What happens? This is a one-dimensional array. So if we want to reshape it to a new array, which is a two-dimensional, which has 4 rows and 3 columns, we can do it so. Okay, so if you give it like this, so what happens? The array which is already given value is reshaped with elements in 4 rows and 3 columns, and it is assigned to new array. So now if you print the new array, you can find a new array with 4 rows and 3 columns. So you can do the same thing for an convert the one dimensional to 3-dimensional arrays. Okay, so you can have 2 rows, 3 columns, and 2 frames. Okay, so like that the elements will be arranged. Okay. Okay, now a question arises, can we reshape any one-dimensional array to any shape? Yes, it can be done as long as the total number of elements in the one-dimensional array is equal to number of rows multiplied by number of columns multiplied by number of frames. So or if both are equal, then we can very well reshape any matrix into any other shape matrix. So for example, see here, 1, 2, 3, 4, 5, 6, 7, 8. Totally, we have only 8 elements here. But if we try to reshape it to 3, comma 3, which requires actually, see 3 star 3, if you multiply, it requires 9 elements, but there are only 8 elements. So what happens? An error will be thrown. Okay, so that is the major requirement for reshaping any matrix into any other matrix. So flattening the array. So what do you mean by flattening array? Converting any dimensional array into a one-dimensional array. So if you give it like this, array dot reshape of -1. So what happens when you print them? You can see this two-dimensional array is converted into a one-dimensional array and it is printed. So same function can be achieved by means of using all of these functions like flatten, ravel. Okay, so all of these functions can be used to convert a multi-dimensional array into a single dimensional array. So next we are going to see about introduction to pandas. So actually, pandas is a open source data manipulation and analysis library used in Python. So it actually works with data frame and series. Okay, so the major use of this is to work with the data fast, easily, and to explore them easily. Okay, so pandas are widely used in data science, machine learning, and data analysis for tasks such as data cleaning, transformation, and exploration. Okay, so series is just like an array and it can hold any data like integer, float, or string. So it is actually labeled like your array. It also contains or holds an index. So series is defined as a column in a spreadsheet or a single column of a database table. So series are actually the fundamental data structures in pandas and they are widely used for manipulation and analysis tasks. So list or arrays or dictionaries or existing series objects from all of these, generally series can be printed. Okay. So we'll see examples for that, how to create a series. Okay, so consider this is a data 1, 2, 3, 4, 5. So if you want to create a series from this data, you have to use PD. You have to import pandas. See, in the previous case, we have imported numpy, right? Same way, you have to import pandas here. So what happens? You have to give PD dot series of data. So the array which is defined here is now will converted to series. So if you print it, you can see 1, 2, 3, 4, and 5. Okay, are I mean the data which you have given. Okay, it is converted to series. One important thing you have to notice: any data in series will be assigned an index value. By default, if you do not specify any index value, it takes the values of 0, 1, 2, 3, 4, and so on. You can also customize the index values, so which we will see now. Okay, so if we give like this, okay, so data equal to quote single quotes a is to 1, b is to 2, like this. And if you convert this data into series and if you print it, you can clearly see the index values are assigned as A, B, C rather than using 0, 1, 2. And the corresponding values are stored as 1, 2, and 3. Okay. Similarly, third case is customizing the index. Okay. So, what happens? Data is given separately and index is given separately. You are creating a series with the data and the index. So, if you do so and if you print it, so first data will be mapped with the first index and so on. So it will be printed like this. So this is how series works in pandas. So we can see as each element in the series is associated with a particular index, we can specify the index and we can extract the data corresponding to that index. Okay, so from the list 0th element, if we print, it will show 1. From the dictionary, if we have to print the value corresponding to index B, that can be 10. So vectorized operations. So operations, arithmetic operations can also be performed on series as we have done in array. So we are defining two panda series. So we are doing an arithmetic operation addition here for both the series. And if we print, then what happens? 4 plus 1 is added to 5, 5 plus 2 is added to 7, and 6 plus 3 is added to 9. And okay, and one thing you have to note, see, adding two series will also be stored in a series. Okay, so what happened? It has by default, since we have not assigned any index values, by default it is taking 0, 1 and 2. So next comes the see what happens here. The series is given as 1, 2, 3, and second series is given as 4, 5, 6. So all these are data. So we are assigning index to these series. So first data, no, A for the index value, A value corresponds as 1, B 2, and C 3. Similarly, for this B, 4 is assigned, C 5 is assigned, and D 6 is assigned. Suppose if we are performing addition in such a cases, you have to very clearly understand addition will be performed only if both the index values matched. Okay. So here B and B, both the index values matching. So corresponding values are 4 and 2. So if you add it, 6 will be stored here. Similarly, here C and C is matching. So corresponding values or data are 3 and 5. So both will be added and 8 will be stored. So you can ask me what will happen to A and D. Since only in the first series, index value corresponding to the data 1 is A. And similarly, to the second series, the index value corresponding 6 is D. Addition cannot be performed since we do not have a corresponding value for A in second series and value for D in first series. So what happens? NaN will be stored in the place. Okay, so NaN means not a number. Okay, so handling NaN. Okay, so as I've told you, another example is shown here, not a number. Okay, so you cannot add a number with a, empty space. So it results in a NaN, which means not a number. So what happens in other cases, in any other programming language, an error will be thrown telling that addition cannot be performed since the index are not matching, but that is not the case in Python. So since you are using pandas, it can gracefully handle if the index do not match, it straight away fills the place with the NaN, which represents not a. Okay, thank you.